Hey Fadhli, do you know about the IEEE? And do you know how to convert IEEE to decimal number?
Don't worry about that. I will teach you. Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Fadhli IKRAM bin ABDUL HALIM. Today I will explain about IEEE and how to convert it to decimal. First of all, have you ever wondered how computers store decimal number or real number like 1.78 or 0.97? Unlike human, they not store the number directly. Instead, they use the IEEE form, which is the standard international format that define the real number in three main parts. First is sign, and we got bias exponent, and finally we got mantissa. IEEE value is easier because it is compact. One hexadecimal represent 4 binary digits. This makes IEEE value easier to read, store, and debug in low-level programming and memory dump. So, I have 7 steps to convert IEEE to decimal number. Let's get into it. So, for the first step, we need to convert the hexadecimal value into the binary form. So, here's the given example. And we need to convert it into the binary using the magic table. It is easier way to convert the hexadecimal into binary using the magic table because one hexadecimal number equal to 4 binary digits. So, we will get the answer like this. Okay. So, for the second step, we need to put our binary value that we convert previously into the IEEE table. IEEE table, I mentioned before, has 3 sections. The first section is sign. Sign only has one binary digit, and it is important when determining our final decimal value will be positive or negative. 0 for positive and 1 for negative. Move on to the next section, we get bias exponent. Bias exponent has 8 binary digits. And final section is significant, which has 23 binary digits. And you will look at the significant has lot of 0000, like our example. So, in this step, we need to divide the binary digit and put it on their section. 1 binary digit for the sign, 8 binary digit for the bias exponent, and 23 binary digit in significant. Okay. So, for the third step, we need to get the bias exponent. How do we get the bias exponent? By referring to IEEE table, we need to look at the section bias exponent that we get from the previous step, which is in the binary digit. We get the binary digit and convert it into the decimal. Using the traditional way, we will get the 133. After convert it to the decimal number, which we get the 133, we need to subtract it by 127. And we will get the Y value. Y value stands for the exponent, which we will use it in the next step. Take a note here, don't make a mistake when calculating the Y value, because if we get the wrong answer for the Y value, it will impact the final result of our decimal value. So, after subtracting it, we will get y value equal to 6.
So, for the fourth step, we need to get the mantissa from the significand. Significand has 23 binary digit, and we're not gonna use it all the binary digit. Using the y that we get from the previous calculation, previous step, and we will find the mantissa. I will explain this step more in the step 6 later. So, for this step, we only need to recognize the significand first. So, for the fifth step, we need to get the sign. By look at the IEEE table at the sign section that has only one binary value. So, that value will determine our final decimal value that we will get it later. But we need to determine the positive or the negative. If we get 0 on the sign, our final decimal value will be positive. Otherwise, if 1 at the sign, our final decimal value will be negative. That's all for this step. But it is important to us to not forget the sign after we convert into the decimal, because it will impact our answer.
For the step 6, we need to put our mantissa in format 1.xxx. What does that mean? That means we need to put 1 in front of our number and then put n dot. Okay. Please take a note here because students always forget to put the 1 on the front, and then they will get the wrong answer because they have less one number in front of their number. Okay, move on to our step. We need to refer for our y. The y, which is the exponent that we get from the step 3 from the bias exponent, which our y is 6 in our example. So, after we know that our y exponent is 6, we need to do this for the 6th time. 1, 2, 3, 4, 5, and 6. And then put a dot here. Okay, after that, we need to get only the front number of the dot. And the remaining 0 will be removed. So, we only get the number here. 1, 1, 1, and 1. 0, 0, 0. So, this is the step 6. As I remind you, again, we need to put 1 in front of our number, and then we need to refer to the y exponent, and then we do this 6 times based on our y, and then we only get the front number, and then remove all the 0 at the back. That's for the step 6. For the step 7, we need to convert our number that we get from the previous step to decimal. So, we convert our number to decimal as usual. 0, 1, 2, 3, 4, 5, 6. And then we do 1 multiplied by 2 power of 6 plus 1 multiply 2 power of 5 add 1 multiply 2 power of 4 and then add 1 multiply 2 power of 3. And then our value will be 64 plus 32 plus 16 and plus 8. Our decimal value will be 120. So, this is our decimal value. But we don't finish it here because we don't know our number is positive or negative. So, we need to refer for the step 5, which the sign. So, our sign in the step we getting before is 1. As I said, if we getting 1 on the sign, our number will be negative. So, our final value will be negative 120. So, this is our final answer.
So, in conclusion, by understanding IEEE, we can understand how computer store and process real number internally and why some floating point number may be calculated inaccurately. That's all from me. Sorry if I make some mistake in this video when explaining all the steps. And hopefully you will learn and improve your understanding about IEEE and how to convert it to decimal. That's all from me. Thank you.